This video will allow you to finish the back part of the vector worksheet and also is meant to provide you with extra practice of how to add vectors algebraically, meaning using the components. So in this example, we have three vectors to add. There's a 25-meter vector at the angle of 25 degrees northeast. So if you were to doodle it, you have direction east. So this would be east. And you're going 25 degrees off of it. So this is what it should look like. 25 meters at 25 degrees northeast. Now, if we were to look at the components that this vector will have, it will have a vertical and horizontal component. To find them, you're going to make the right triangle, as we did before. So this will be your y component, and you're going to use sine to figure it out. So this will be 25 sine of angle 25. And then the x component, which is close to the angle, will be found as 25 times cosine of 25 degrees. So I already used a calculator to figure it out. So if you put 25 sine of 25 into your calculator, you will get 10.6 meters, providing you are in degrees, which you should be in. And your horizontal component will be 22.7 meters. Again, you need to be in degrees in order to get that answer. The next vector is directed west of north. If this direction is north and we go west of it at 60, that is what it should look like. So this right here is the 44 meters, and it is at 60 degrees west of north. Now, the thing is, for x and y components in this case, we're still going to use trig, but now sine is going to be used for x because it's across from the angle, sine of 60. And remember, since it's pointing to the left, it's going to be a negative number. And then for y, we're going to use cosine because it's close to the angle. So it's going to be 44 cosine of 60, negative 38.1 meter for your x component, and 22 meters for your y component. The last vector that we're adding is 75 meters south of west. Now, how do we draw south of west? And it's going to be the longest one. West is pointing to the left, and we're going south of west at 35. So something like that. About 35, let's say that's it, 35 degrees. And it's 75 meters. This will be 75 sine because it's across from the angle like that. And it's going to be negative because it's pointing down. Cosine of 35 because it's horizontal. Both of these components, both south and west, are left and down. Down and left are negative. Negative 61.4 meters for the x component and negative 43.0 meters for the y component. All right, so I repositioned my vectors in order. So first I have here 25 meters at 25 northeast, then we went 44 meters at 60 west of north, and then finally turned around sort of 75 meters, 35 degrees south of west. Now, what would our resultant vector look like? Resultant means what is the sum of all of those vectors. We're connecting the beginning of the very first vector, which was 25, to the end of the last vector, which was 75 meters. And then we're going to look at that vector from its x and y components. So what I see here is the x component is pointing left. This is the x component. And this is the y component, which is pointing down. And the way we did this, remember we wrote down all the values for our components. And then I went down here and added them all in the table. So see how we have the x component and the y component. So now, if you look at all of these, add up. So this is the sum of all x's. So it's kind of ashes to ashes, dust to dust. You add x's to x's and y's to y's. This is the sum of y's, and that is the sum of x's. And then once you get your sum of y's and the sum of x's, just like in the hockey lab, you're going to doodle. So to the left, I have a bigger part, a 76.8 meters. So what I did is it's left because it's negative. So this right here is 76.8 meters. And then the vector pointing down, because again, it's negative. Negative means that it's going to be pointing down, is this 10.4 meters. Now notice that I'm not using the negative. Instead of putting the negative, I'm pointing left for x and down for y. Because of that, I know that x is negative and y is negative, and that is how I know that this, if I measure this angle in this direction right here, what I'm measuring is a south of west angle. Now, first of all, when we figure out the resultant vector, we're figuring out two things. We're figuring out its magnitude and direction. Now, magnitude, again, as always, it's how long it is. In the hockey lab, remember, you measured it with a ruler, and you can also calculate it as your Pythagorean theorem, always working, always trustworthy. You have 10.4 squared, or x squared, plus 76.8 squared, or so x squared plus y squared. And again, because it's a triangle, do not bother about minuses. Minuses just tell you which way it's pointing, left or right, up or down. So once you figure out your Pythagorean theorem, that would give you 77.5 meters if my calculator didn't lie to me. And now when you're figuring out the angle, since I know my two legs in a right triangle, I can use the inverse tangent. For tangent, you always go first, you go across, just kind of point, and then you close. First you see, and then you close. You see, and that's the opposite, 10.4. Or you can also remember, what is 10? 10. Can you 10 in the summer? Sure can. As in sine over cosine, as in see over close. So remember, if you think of a human eye, see is the one across and close is one close to the angle. It's how you close your eye. And the hypotenuse is kind of like your upper lid. Anyway, so inverse tangent will give you the angle. 7.7, it's about 8 degrees. And there we go. So the one that I actually found was this tiny angle right here, which is about 8 degrees, and it is south of west. So right here, about 8 degrees south of west.